Dear all, I am Dr. P. Sabrinath, working as Associate Professor in Mechanical Department at SRM Madurai College of Engineering Technology. This video is about the subject Basic Civil and Mechanical Engineering for second semester EEE students. So I am going to handle the mechanical part. So in the first unit you have the overview of civil as well as mechanical engineering subject. So in this video we are going to see about the overview of mechanical engineering. So mechanical engineering is defined as the branch of one of the core engineering that deals with the design, development, construction and operation of mechanical systems and tools. For example, if you take an example of a car, so car is an example of mechanical engineering product. First we have to start with the design of the various parts of the car components like engine. Engine has piston, crankshaft, connecting rod. So each and every component of the assembly of the car is to be designed first. Then all the components should be assembled as a final product as a car, that is called development. And after the design and development is over, we have to make the product, that is the manufacturing of the product, that is called construction. So each and every part has to be manufactured in any industry, and finally it will be assembled as a final product. Then only we are using as a car. The operation means we have to use fuel like petrol or diesel for operating the car. So all these aspects of starting from the design includes not only the design of the components but also the selection of the materials. For example, if you are designing a shaft, we can use any type of material like alloys, steel, cast iron. So which metal will be suitable for that particular component that has to be designed. The dimensions of each and every product, the size, shape, tolerance, all these things comes under the design part. Then individual design is over, we have to assemble the each part to make as a assembly. At that time we will face lot of problems, so we have to solve all those problems and we have to make it as a final assembly. And after design is over, we have to manufacture it at any industry by using various process like casting, welding, forging, or we can use machines for lathe, milling, drilling, shaping, like that. So many machines are available in mechanical engineering. By using all those machines, processes, the materials will be converted into the products. Then finally, all the products are assembled together to make it as a final car. So this is an example I am saying for overview of mechanical engineering. So it includes the manufacturing of machines, and we have to use many tools for cutting the machines. If you take a lathe, we use a single point or multi-point cutting tool, and equipments used in various industries. For example, transportation, what we have seen is a car or a two-wheeler, a bike. Everything comes under mechanical engineering only. Manufacturing sector, power generation using power plants. There are various type of power plants like steam power plant, hydroelectric power plant, nuclear power plant, windmill, solar power plants, gas power plants. In all those things, we use mechanical engineering to produce the final power, electricity. And recently for medical devices also, mechanical engineering is used. So this is the overview of mechanical engineering. So mechanical engineering is a discipline that applies the engineering physics and material science principles to design, analyze, manufacture and maintain the mechanical system. So we need a basic physics various laws we have studied in physics, Newton's law, first law, second law, third law. All these things we have to apply in mechanical engineering. And material science, just now I told that we have to use materials like alloys or pure metals or composite materials also nowadays used. So those concepts of material science principles also we have to apply for designing the component. Then we have to analyze whether the component will be uh, able to withstand the external pressure or external force. For that we are having a software like ANSYS, finite element analysis concept. In that we can analyze the part with the help of simulation softwares. In that without applying the real force, we can simulate whether the material can withstand the external force, how it will fail, like that structural analysis, thermal analysis. All these analysis can be done using the softwares like FEA, ANSYS, CATIA, etc. That is called analysis. Then manufacturing of products, we can use casting. Casting means we have to melt the metal into a molten stage. Then there will be a die cavity will be there for the required size and shape. In that the molten metal will be poured, and after solidification the final product will be arrived. That is called the casting process. Like that we have so many forging process. We can use various type of machines like lathe. Nowadays CNC machines also used, computer numerical control machines. In that we can do programming using G codes and M codes, and automatically the machining will be done without any manual supervision. That is called automated machines. All those comes under the manufacturing engineering, and maintain the mechanical system. So we have seen various disciplines are coming under mechanical engineering. So let us see one by one. First one is applied mechanics, second one is dynamics, third one is fluid mechanics, fourth one is thermodynamics, fifth one is heat transfer, and sixth one is production technology. The only important disciplines only I have listed. There are so many other areas also included in mechanical engineering. Now let us see one by one. Applied mechanics is a branch of physical science that deals with the practical application of mechanics to solve engineering problems. It involves analyzing the forces, motion, deformation, and failure in structures and machines. If you are driving a car, the external wind pressure will be acting, so that is called the external force. So when we are moving the vehicle, we are giving acceleration, there will be a change in velocity, there is a change in acceleration. So all these will be considered. That is called dynamics. If the object is in a stable condition or static condition, means it will be at rest. That design is called statics. Study of forces and moments in system that remain at rest. That is called statics, without moving. Suppose if the object is moving like a car, that is called dynamics. So in that both motion and forces will be involved. So there are two type of dynamics. One is kinematics and other one is kinetics. So kinematics means only motion will be considered without considering the external forces. That is called kinematics of machines. In the kinetics of machines, both the forces as well as the motion will be considered. That is called kinetics of machines. So the applied mechanics is a very one of the core discipline used in mechanical engineering to solve the various engineering problems. Every industry will have a R&D division, research and development division. In that, mostly mechanical engineers will be involved for doing that analysis. So those engineers will work out on the application of this applied mechanics for the engineering product. They will analyze what are all the forces acting, because of the forces what are the stresses will be induced, whether the material what we are using to make the product will be able to withstand the stresses. If the stresses become more, there will be deformation, that is called strain. The metal will undergo deformation. If it undergoes a plastic deformation, that is called a failure. The metal may crack, the metal may failure, so it will lead to accidents, even death of the users who are using that product. So mechanical engineers who are working in the R&D should be more responsible for designing the suitable product which should avoid the accidents. So they have to consider applied mechanics before making the final product. Like that, some other disciplines also we are using. Dynamics, just now I told you, there are two type of dynamics, kinematics and kinetics. The next one is fluid mechanics. In fluid mechanics, fluid means it may be either gas or liquids. Both are generally called as fluids, because most of the mechanical system will use either compressed air, we use compressed air. Pneumatic system, we call it as pneumatic system, that uses compressed air, that is one type of fluid. Sometimes we use hydraulic systems, compressed oils, like that, they are called hydraulic system. So in the fluid mechanics, how the fluids behave, either it may be a air or liquid, how they behave, what are the forces acting, all these things will become under fluid mechanics. We have a separate subject in mechanical engineering to study about the fluid mechanics. And one more thing is thermodynamics. Thermo means heat, and dynamics, already I told you about dynamics. Because of heat, what are the forces will be developed because of the application of heat. For example, if we take a boiler, we will heat water to produce superheated steam, and that steam will be used to run a turbine. By means of that, we are producing power in thermal power plants. So in all these things, we have to carefully study the thermodynamics. So thermodynamics also has a lot of concepts like various laws of thermodynamics, first law of thermodynamics, second law of thermodynamics, and third law of thermodynamics. Various concepts of entropy, enthalpy, all these things will be studied in thermodynamics. That will be useful for designing components like boilers. Next concept is heat transfer. We have studied in school itself about various modes of heat transfer, conduction, convection, and radiation. So those things also we have to apply in mechanical engineering whenever the heat is involved. So conduction means within a medium, the heat will be conducted from one place to other place. Within a solid or within a liquid is called conduction. If the heat is transferred from one medium to the other, heating water, first the heat will be given to the vessel, that is solid. Then from the vessel, the heat will be transferred to the liquid, that is called convection. Radiation means without any medium, the heat will be transferred. For example, we are getting heat from sun, so there is only vacuum is there. So without any air medium, the heat will be transmitted. That concept is called radiation. So all these three concepts of heat transfer will be operated to design the components in mechanical engineering. Next one is production technology. In production technology, we are going to study all type of processes like casting, welding, forging, all type of machines. It is a separate discipline of mechanical engineering, in which we are going to study all these process of manufacturing a component and finally assembling the final component. So, mechanical engineering contributions to the welfare of the society. So, mechanical engineering contributes a lot to the welfare of the society. It produces very cost-effective products for transportation. Already I told you about the car, power generation, power plants, defense mechanisms, in agricultural fields, latest smart materials. All these are contributions of mechanical engineering for the welfare of the society. So already I told you various processes like mechanical has lot of disciplines like manufacturing engineering, design engineering, thermal engineering, energy engineering. So one of the sub-discipline is manufacturing, in which we have so many processes like metal joining, like welding, metal casting. In that we will molten metal will be created by heating the metal, and that will be poured in the die casting, and the products will be manufactured after solidification. Then metal forming process like rolling, forging, then machining process like lathe. So these are all comes under manufacturing stream. Then one more sub-discipline is energy engineering. So we know the law of conservation of energy. So energy will be converted from one form to other form. So we can convert mechanical energy into electrical energy, chemical energy into mechanical energy, nuclear energy, nuclear power plant. Nuclear energy is used for producing power, sound energy, heat energy. So all these things will be studied in energy engineering. So finally, recently mechanical engineering is mainly used for automation. Automation means without any human application, automatically the process will be carried out. So nowadays many driverless cars, bulletproof cars, anti-lock braking system, recycled car, hydrogen car, metro train, bullet train, all these things are example of recent applications in mechanical engineering. Thank you.